exhibits kind of maybe the name of the town that he grew up in and what cheer. Adam is usually carrying a fair amount of cheer with him. So it's an appropriate name, or I guess appropriate offspring from the town. But Adam will talk a little bit about his efforts. Adam also began his career, really, his working career with Bayer Crop Sciences in March, and has been working there as a technology development representative. And so he's been quite active and I think quite concerned working through the summer trying to write this doctoral document and getting all the work that he had been doing as well. But he's been burning the candle at both ends, I think, a lot of weekends. So he's got this done in good time, but hopefully now he can move on after this and finish up his harvest work. So I'll turn it over to Adam.
Thank you. You turn it off? Did you turn it off? Okay, perfect. I'm assuming, unless anyone says anything, that you guys can hear me. So we'll go ahead and just get started. So first and foremost, Dr. Hein, thank you for the introduction. As he said, my name is Adam Striegel, and today I have the opportunity to present my final defense seminar, The Intricacies in Agronomic Management, the Role of Interdisciplinary Education. So let's go ahead and get started today. And it doesn't move. There we go. We are back in business, boys and girls. So for the agenda for my seminar today, we're going to have 4 sections. And as we transition from section to section, I'll briefly go over the agenda for that individual section. So the first is introductions. I'm going to provide a brief review of the DPH program, as well as my background and internship experiences. And so what is the DPH program? For those of you that aren't familiar with our program, it's a little bit different than most doctoral level programs. It is an interdisciplinary doctoral level plant practitioner's degree that's unique to the University of Nebraska-Lincoln. One of the main constituents and components of the DPH program is a very intensive course load, specifically 100 credits at the graduate level in a lot of different agronomic disciplines. So that includes plant pathology, entomology. We're looking at 16 credits each, and you can kind of go down the list to see what our educational experiences are. But in addition to our classroom experiences, there's a research practicum for 4 credits, and then there's 2 internship experiences totaling 6 months in length. And so the internships that I had during this program, actually I should probably show just a little quick snippet of our program. So this is to help connect some faces to names. This is the current DPH program that we have, and it is important to note that some of us, we have moved on, maybe not to greener pastures, but we have graduated. But this is to kind of give you an idea for the size of our program. So with that, I do want to quickly discuss my background. So as Dr. Hein mentioned, I'm originally from Southeast Iowa, of the town of Wattier. We pronounce it Wattier because, well, we're in the 3rd tier of Iowa. But after high school graduation, I headed to Iowa State University, where I picked up a bachelor's degree in agronomy, specifically in crop management and business. And then after a short internship that summer, I headed to UNL to begin the DPH program. Now, from the fall of 2016 till now, I had the opportunity also to add a master's degree with Dr. Amit Jalla in weed science. This is just an abbreviated form of the 2 thesis projects that I had. But I do want to direct your attention here to the bottom right-hand corner here at these beautiful smiling faces. What a gorgeous background. That's in Maui, Hawaii, and that would have been taken March 2020 before COVID-19. So all those unworried smiles, what a beautiful time. But moving on to that, my internship experiences, the first one I'd like to just briefly discuss is with the University of Nebraska-Lincoln, and this was conducted from 2017 to 2021. Specifically in this internship experience, I had the requirement to essentially create a course. When I arrived at UNL to start the DPH program, there was no organized class or structured environment for the students that wanted to compete at NACTA crops contests. And so I created a 1 to 2 credit class that I taught in both spring and fall semesters for students that were interested in these contest experiences. And I will go into depth of what the NACTA crops judging contest is later in this presentation. There's a lot I could talk about here. The main snippets I'd like to just briefly mention. is that when I created the course, I had to create all the course content as well. And that includes a 225-page handbook that I had to make, which I'm immensely proud of. But then I also had the opportunity and joy of growing over 100 species in the greenhouse each and every semester for plant ID labs. That was a lot of fun. I got to practice my green thumb. And then, and if you talk to any of my students, and here are the teams throughout the years, they're going to probably say the same thing, that I've always stressed that their successes are theirs. They're not, the success that we've had in this program does not represent my successes. It represents their successes. And so my students have been very, very successful, placing in the top 3 at 15 of the last 17 contests since 2017. And you can kind of see a trend here in the top right-hand corner of our scores that we have come relatively close to the winning contest teams throughout the years. So that's exciting. But moving on into my second internship experience, this is with Central Crop Consulting, specifically with Dr. Lee Breeze in North Dakota. So I was able to use this internship experience for the second internship requirement, and I conducted this in the summer of 2020, and this was an absolute fantastic experience for myself. And I think probably many of the students that have had the opportunity to work with Lee, whether they're from our program or from NDSU, will probably say the same thing. The really unique aspect of this experience was basically identifying some of these agronomic problems in a diverse cropping system. So coming from Southeast Iowa, corn and soybeans are in my back pocket. I have those under control. But when we start to deal with dry beans, spring wheat, barley, flax, oats, rye, field peas, sunflowers, and then prevent plant situations where we're doing cover crop mixes, I'm being exposed to a diverse cropping system with new agronomic issues. And so what I really viewed this as is I was allowed the opportunity to integrate some of these disciplinary classroom knowledge experiences, concepts, constructs that we discuss in undergraduate and graduate courses, but out into the real world. And so it was a very good experiential learning opportunity for me. The one thing I did tell Lee I would stress, ability to read maps. Regardless of if you're a graduate student or an undergraduate student, everyone starts the summer not being able to find fields. And so learning how to read maps is critical. Before I move on, just some photographs here. On the far left-hand side where my pointer's at, this is a desiccated field pea field that is ready for harvest. Then the next photo here, these are bug lollipops, as Lee likes to call them, otherwise known as sunflowers. So insect management is very critical for that crop. We have a saline soil area right here, which obviously is not going to be very productive. This is a gorgeous wheat field with a nice tree line in the background showing you that North Dakota can absolutely be phenomenally beautiful. And then last but not least, a different type of beauty. We have a terminated cereal rye cover crop that we've planted dry beans into, and they're starting to come up within the rows. So a different type of beauty, but still beautiful. But with that, I'd like to move on into the second section of my presentation, and that is the foundation of agronomy. This constitutes the first chapter of my doctoral document. For those of you that either had the pleasure or displeasure of having to read it, or those that are planning to read it, it's about 80 pages long. Can't really fit that into a seminar. So what we're going to discuss today is just defining what agronomy is. We're going to introduce G by E by M, and we're going to discuss some management considerations before we move on to section 3. And so the first and foremost we have to do is we have to define what agronomy is. And so depending on who you are and what you're doing, you might open up a dictionary to find a definition. I chose to use the American Society of Agronomy's definition. They seem pretty reputable as it pertains to agronomy, my personal opinion. So I'm going to read this quote here, but the American Society of Agronomy says, agronomy looks at agriculture from an integrated, holistic perspective. Agronomists are specialists in crop and soil science as well as ecology. And so I kind of took two main snippets from this definition. The first is that it's an integrated science. We're talking about multiple disciplinary sciences that have been incorporated together. The next component is that it's a holistic perspective. So we're talking about a comprehensive view on the complete cropping system, not just one or two components, the entire cropping system. And so that led me to a theoretical model that I'm presenting today for my seminar. And that is the way I view agronomic management. And it didn't quite come out the way I was hoping, in that it was supposed to look like a gear, like that you'd put into an engine. But essentially, we're looking at the culmination of soil science, plant physiology, plant breeding, field entomology, plant pathology, ag economics, plant ecology, and last but not least, weed science. So that is the way I have chosen to view agronomic management. And so I think now that you've seen how I'm choosing to define agronomic management, I think it's important to discuss how we're measuring success in our cropping systems. And so namely what we're looking at typically is some type of economic determination, whether that's economic return on investment, a nitrogen use efficiency for our over efficacy amounts, not net profit ratios or cost benefit ratios. All of these equate back essentially to crop yield. What is the production per acre? And so I think it's important to discuss the traditional yield model, which is genetics, G, plus environment, which is E, plus the interaction of G by E, which is genetics by environment. And so that is the traditional yield model that we typically use. And to help illustrate this, this is a photograph of U.S. historic grain yields from about 1850 to, and this is going to be forecasted into 2030. And specifically what we're looking at here on the y-axis in bushels per acre, you're seeing in these yellow dots with our open pollinated varieties in the past, our yield potential has been significantly lower. But as we've transitioned into our modern hybrids here in these blue dots, the yield potential has increased dramatically. So we're seeing a direct correlation to genetic improvement from our crops. But it's not just genetics. And this was illustrated by a study that was done in Story County, Iowa, which is where Ames and the Iowa State University, is located. And what we're looking at, and this was their forecasted attainable yield here in this graph, in this nice dark black line. And as you move through the years from 1950 to 2020, our yield, you can see it's increasing, very similar to what we're seeing in the US grain yields. But then underneath it, you're going to see a jagged line that kind of goes up and down, up and down, up and down. That is the actually attained yield within Story County for their corn producers. And so what you're looking at here in the bracket down at the bottom, that is essentially our yield gap, the separation from what the attainable yield is, or at least what these authors recommended for a attainable yield, and what was actually obtained. And so that kind of relates back to agronomic management. So not only has our genetics changed with time, but also our management as well. And so an expanded yield model would read yield is equal to genetics plus environment plus management plus the interaction of G by E by M. And so the way I look at that is that we're selecting G by M, we're selecting management that leverages varietal differences, crop species differences, as well as crop traits. From an E by M, we're looking at management that alters suitability for crops, pathogens, and pests by management. And then a G by E by M interaction. Now we're talking about those interactions that we can change through agronomic management. And so this kind of culminates because it's kind of a little wishy-washy at times. What it really comes down to, and I want you to think about this over the next few slides, how has our agronomic management changed since 1950? Pretty significantly, but I'll let you think about that. But with that, I have a few management considerations I want to briefly discuss before we move into the next section. And the first is soil science. So these are some really interesting photographs that Dr. Lee Breeze up in North Dakota sent me. And what we're looking at here, this is a production field right next to an unfarmed area of the field as well. And if you didn't notice this, there's a little bit of a terrain change here, about 1 to 2 feet. So essentially in our farmed portion of the field, we've lost 1 to 2 feet of topsoil. So thinking about that from a management perspective, that creates some significant issues as it relates to economic value and production, and how we manage this field has now changed. And then this other photograph from Lee as well, I believe he's headed north on Highway 281. I could be wrong on the number, but that helps you illustrate that this doesn't just happen overnight. It's happening continuously still to this day. So changing our management to mitigate these changes now is most likely a better representation than trying to fix a loss of 2 feet topsoil after the fact. But moving on into weed science, this is kind of my bread and butter with my experience with Dr. Amit Jalla. These are some plots that I did for some Bayer research trials. What we're looking at here is a corn hybrid, same hybrid. And what I would like to just directly point out to you is that in the non-treated control plot, plot 101, we're seeing significant drought physiological responses from our corn hybrid. We're seeing a lot of rolled leaves. Compare that 20 feet away to a treatment that did receive not necessarily 100% because there are percent control of the water hemp because there are a few stragglers here and there. but just that stark difference 20 feet away really helps illustrate the importance of weed management as it relates to competition for soil nutrients and soil water. And then the last slide here for our management considerations. This is, again, we're starting to add on entomology and plant pathology into weed science. So this is a photograph that I took on my way to Atlantic, Iowa, in western Iowa. This is a rotated soybean field with a substantial, almost terrifying population of volunteer corn. So from a weed management perspective, that's going to cause direct yield loss because a volunteer corn can act as a very competitive weed. But from an entomology standpoint, we've now created a very palatable habitat for western and northern corn rootworms to come into the bean field and lay their eggs, essentially circumventing our crop rotation. And then if we look at it from a plant pathology standpoint, we've now created a host, and now all we need is the other two components of the disease triangle, and we're going to be creating an increased inoculum load for the next year after we rotate back into corn. And so that kind of leads me to my last photograph. This is loose smut of wheat. There's not a lot to say about this, but the main point being is understanding the biology of each and everything that we have to manage in our agronomic systems is absolutely essential. This is a seed-borne seed-borne disease. And the best management strategy is planting certified seed that we know does not have fungal infections, or a fungicide seed treatment. Coming in with a broad acre fungicide after the fact is wasting your money. Understanding the biology of your pests and how to manage them is essential. And so that leads us into the need for interdisciplinary education, specifically that effective agronomic management will require comprehensive knowledge that it's across multiple crop disciplines. And so here is my model again to help illustrate that. But let's move on into the third section, which is agronomy education in the Midwest. This is chapter 2 of my doctoral document. And so today we're going to discuss, some historical perspectives on collegiate education. We're also going to discuss the program of studies survey that I conducted, as well as the survey results and discussion that I'm going to provide about the survey. And so when it comes to essentially anything in life, understanding the past is essential to understanding the present. And so I wanted to provide some quick historical perspectives about collegiate education, specifically how it's evolved. So from the early to mid 1600s to the late 1700s, the main emphasis for collegiate education in North America was on Bible studies, specifically to promote social propriety and morality of college-educated gentlemen, if you will. In the 1850s, there was a little bit of a change. Harvard and Yale specifically started a 2-track system. One track was for all law, medicine, and ministry positions. And then the other track was, quote, all other professions. So that includes any of our vocational training programs and majors that we know of today. Additional context is needed, though. In 1862, Morrill Land Grant College Act established federal funding for land grant institutions. And just a few years later, the University of Nebraska-Lincoln was chartered. And so that helps put things into some historical perspective. But allow me to just briefly discuss the pressure for educational reform and standardization that was taking place during that time period as well. And so from 1850s to the 1900s, there was a lot of pressure to standardize the length of these academic programs, how many years students had to go to college in order to complete this degree. And then also determining the age of eligible students. I thought this was really interesting. High school versus college was not always the fine divided line that we now have. Back in this time period, you could be 14 and going to college. And so making these standardizations was important. And the one main thing that drove that actually was the American industrialist Andrew Carnegie. Specifically, and this is funny, once you start to put money at things, things happen, a national pension program. So in 1901, he established a national pension program for, and I'm going to quote his direct words here, the poorest paid but highest professions in our nation, which was college professors. Now, to today's standards, this would equate to roughly $250 million. So that's it was a pretty generous gift at the time. And even with this generosity, it was not sufficient for all educators in the United States. So to circumvent this, essentially, the Carnegie Board of Trustees partnered with the National Education Association to develop academic standards for who was and who was not eligible to apply for this pension program. And all this culminated into the Carnegie Unit. which is a standardization of coursework based off of time requirements. Now, this does look a little different depending on if you're on a quarter system, trimester system, or semester system. But essentially what it equates to is 1 hour a week for 15 weeks would equal 1 credit hour. And then 4 years of 30 credit hours each would equate to 120 credits. Does that sound familiar? It should, because derivations of this Carnegie unit are still used to this day. In fact, all the programs of study that I surveyed use 120 to 128 credit hours for their degree requirements. So this is still very, very important. Now, I should mention for the educators in the room, there is a lot of discussion about whether time-based units is more appropriate than competency-based units from a learning perspective. That is not the discussion for our conversation today. And while that would be a nice, robust discussion we could have, well, we're going to continue forward on this presentation. And so that leads me to the agronomy survey objectives for this project. Specifically, we wanted to survey existing undergraduate degree programs in agronomy across the Midwest and Upper Corn Belt. Specifically, we were looking for commonalities in these degree programs, as well as we wanted to report degree program strengths and weaknesses, or as I would like to refer them as opportunities for improvement, always the optimist, if you will. And so that leads me to the survey locations that we selected. There's a map here that you guys can look at here. What we selected was Iowa State University, K-State University, NDSU in North Dakota, Ohio State University, Purdue University in Indiana, SDSU in South Dakota, the University of Illinois at Urbana-Champaign, University of Minnesota Crookston, University of Missouri, University of Nebraska-Lincoln, and University of Wisconsin-Platteville. So in total, 11 universities were selected for this survey. Now, the materials and methods for this survey, the programs of studies were obtained from the online official websites for these each prospective university. And in the event that I wasn't able to obtain it that way, I would email the curriculum directors to get a direct copy of their programs of studies. Now, once we were able to obtain these, we would then have to select an undergraduate major and option. And so what I chose to do was the option that's best aligned for a career in agronomic management, crop consulting, and crop production. So this was a judgment call on my end. But even with those judgment calls, a lot of standardization was required because a lot of these universities, as you move from university to university, how they report their degree requirements vary significantly. So in some instances, they would directly say what things were for, what was gen eds, what was not, and other instances they would not. And in addition, you start to add the specialization levels. So we can talk about degree options, degree concentrations, degree focuses, degree subplans, degree plans. It gets a little messy. And so what we chose to do was standardize this all down into major and option. Specifically, the universities in this table here on the left-hand side, their location on the middle, and the selected major and major option that I ended up picking for each program is listed on the right-hand side. You'll see in some instances, agronomy is listed as a major. In others, it's listed as an option. In some, it's not listed at all. The point being, that is just terminology. I'm picking the most appropriate degree program that they offer at each university. And then I should mention, SDSU does not have any major options. Iowa State does not either. They do allow a 15 credit personalized option, though, that I then included later, but there's no name for that, so it's not included. So once this was done, we decided to separate the curriculum into general degree components, and this was done on a course-by-course basis, as there was not a standardized way that these universities chose to report their data. And so what we separated this in was general education and prerequisite courses, the agronomy major and option, as well as electives. And so I think it's important to just briefly discuss what a general education or prerequisite class is, because this was something I personally defined and manually transferred credits into this. So the way I view this was orientation classes, academic success classes, social science classes, humanities, oral and written communication classes, college chemistry, biology, physics, as well as algebra and calculus. So these are all courses that are typically required from degree components or degree programs, but not directly related to agronomy in any conceited way. But I want to just get into the results from the general degree components because we have a lot of presentations still to go. And so in the next few slides, all of these graphs are going to be the same. On the y-axis here, we have credits from a scale of 0 to 70. On the x-axis, and in really small print for those of you that are in person, I'm sorry, we have the university abbreviation as well as the credit requirements in parentheses here. And this will go from Iowa State University to the University of Wisconsin-Platteville. And in this last column here, we have the overall study average across all 11 universities with standard error. And so on average, across all these universities, from a general education and prerequisite experience, we're looking at 48.7 credits that students are required to take of general education courses. From an agronomy major perspective, on average, we're looking at about 40.5, so just slightly lower than the gen eds. From an option perspective, so this is their further classification and specialization within a degree, that is 25 credits. And I do think it's important to note that the University of Nebraska-Lincoln was a little bit of an outlier here in that most of their coursework that's agronomically related comes in the option that they select rather than their major. So that was a little bit of an outlier in this data. And then lastly, but not least, we have the free electives. So these are courses that either were specifically stated in the programs of studies that students get 7 to 9 credits that they can use whatever they want, free electives, general electives, or it was the total after I take this number minus the other 3 components. Sometimes I had to do that. But on average, 11 credits for free electives. And so the way I chose to look at this after I did all that analysis was that the major plus option plus electives equates to the total opportunities a student has to receive agronomic training during their undergraduate program. And so on the minimum for this, by the way, was Ohio State with 64 credits. UNL was the max at 85.5 credits. But on average, we're looking at 74.2 credits, plus or minus a standard error of 2.8 credits, which equates to 61% of the average course requirements across all 11 universities. So essentially 60% of their degree program is available for agronomic training. But there are some significant limitations to this analysis. And the main point being is that this doesn't quantify the amounts or types of agronomic training that a student is receiving, just the total opportunities. So we needed to look at this a little bit closer. And so what we ended up doing is we separated the agronomy curriculum for each of these programs into disciplinary categories. And so I started first and foremost with 6 categories, and that was plant-focused courses, soil-focused courses, crop protection, technology, electives, and other. And we'll get to that in a moment. And then after this, I then further separated these 6 categories into 20 subcategories. And so in the next few slides, we'll run through those results. And so this is the overall category analysis. So separating that agronomy curriculum into components. The highest was plant focused with about 27 credits. Electives constituted about 25 credits. Other category was 18 credits. Crop protection was 13 credits. And then soil focus was about 9 and technology was about 3. But let me break this into subcategories though, because I think that's a little bit more meaningful than these broad terms. And so the first is our plant focused courses. So this was the highest credit course requirement for our categories. And so 27 total credits. In these graphs, and they'll be the same across the next few slides here, and this is an inverted graph, but on the x-axis, we have our credits and universities on a scale of 0 to 12. So the number of credits required are going to be in our red bars, and then the number of required universities is in black. And so on the y-axis, we have the category or subcategories within each individual category. So within the plant-focused category, there was crop production and crop sciences, botany, plant physiology, plant breeding and genetics, and agroecology or ecology. And so on average, just to briefly run through this, about 7 credits of crop production classes, 5 credits of botany courses at roughly half the universities. So that was replacing biology, which I'll discuss in a few slides. Plant physiology, 4.4 credits required at 8 of the 11 universities. Plant breeding and genetics, a 4-credit experience at 5 universities. And agroecology, a 3-credit experience required at 4 universities. Moving into the next category here, we have our elective courses. And so this is separated into 2 big camps. These are big chunks. The first here is our general and free electives. So that's from our general degree requirements. That's still present within this analysis. So these are still general and free electives that students can use however they see fit. Although within their agronomy curriculum programs for either their master's or their major or their option, there's about 13.7 credits of flexibility baked in on average across these 11 universities that students can use to really place courses that meet their career needs or their personal interests as they see fit to some degree. Typically, these are within a list of selectable courses, and we'll discuss that in a few slides as well. But then that leads us into the next category here, which is the other focus. And this right here, this is business and economics, international ag, animal science, capstones, meteorology, and internships. So the highest component required at almost all the universities, so this is 9, would be business and economic courses. And so this could range from Econ 101 to farm business management to any other economic course that would be appropriate for a agronomy major. International ag, there was 3 universities that required an international ag experience. So that could be a international ag class, or it could be a study abroad. Animal science, only 1 university required animal science, 3 credits, and this was at the University of Nebraska-Lincoln. Capstones, 6, about roughly half the universities required a 3-credit experience. We'll talk about capstones as we move forward. Meteorology, 1 university required meteorology, and that was Iowa State University. Then moving on to the internship experiences, 8 universities required some level of internship class, equating to about 2.7 credits. And so with that, that moves on to the crop protection focus. And so I'll just to briefly summarize this: plant pathology, weed science, entomology, 3.5 to 3.3 credits. We're looking at 1 course on average, maybe with a lab, and that was at 8 to 9 universities of the 11 surveyed. It is important to note, though, for our integrated management systems down here, it is a little bit different. So we're looking at more of our integrated management programs. So we're talking about integrated pest management, integrated weed management, anything that we're incorporating other methods of control besides pesticides. That was only required 2.8 credits at 4 of the 11 universities. And so that's, I think, pretty significant. And you'll hear me talk about that in a few slides as well. But moving on, these are the last 2 categories on one slide, just to save some time and space. So this is soil classes, soil science and soil fertility, on average 9 credits roughly across all the universities. So pretty robust training. And then precision ag, a 2.8 credit experience on average required at 6 of the 11 universities. And so there was a lot of information on those slides, but these are my main takeaways for program strengths. The first is the flexibility that's being offered within agronomy elective and selective. So we're talking about 13.7 credits of flexibility that students can use and place how they see fit to some level of degree, because a lot of times they are required to select from a given list. The next would be the robust training in soil science and soil fertility. So 8.8 credits, round that to 9. That's 3 credit experiences that students are getting at the undergraduate level for a degree in agronomy. There was a focus on crop production and crop sciences, 6.9 credits in total, as well as some significant training within business and economics, 5.4 credits of training in that area as well. And then last but not least, I have 2 other components, and this, I was very surprised by this, and I was very pleasantly surprised, and that half the universities surveyed replaced college biology with botany. I love that idea. College biology, while it is important and it does provide a pretty robust training within the field of biology, is not as focused as I think a botany class would be if you know you want to major in agronomy. And so that was exciting. And then also internship experiences, 8 of the universities required an internship experience and had a class on roster to discuss them after the fact. So that was fantastic. But moving into the weaknesses or opportunities, I'd like to say, we have limited coursework and crop protection, specifically lack of integrated management courses. So this is a 2.8 credit experience only required at 4 universities. Now, some of these concepts can be discussed within other courses, but not having a separate course limits how much time you're able to spend on those discussions, as well as reduced academic training within each discipline. So we're looking at, again, 3.3 to 3.5 credits. So that's a class maybe with a lab. So you have, and I was doing the math in my hotel room this morning. So if it's a 3-credit class, that's 45 hours, I believe, across the universe, across the whole 15 weeks to learn everything you need to know about plant pathology, entomology, and weed science for your career. That's a little limited in my mind. But the main component is that it's not required for all programs. 8 to 9 universities had direct coursework requirements in these areas, which means some universities did not. Moving on, limited emphasis on ag technology, specifically precision agriculture. It's relatively new in comparison to some of our other disciplines, but it is absolutely integral as we look at the way our industry is modernizing. And so that was only required at 6 of the universities. And then also limited emphasis on system level courses, specifically agroecology and ecology classes. These are our system level approaches, looking at the whole picture. 4 universities, 3 credits. So not exactly a commonality in terms of required coursework. And then the main and final discussion would be the lack of capstone implementations. So from an educational standpoint, capstones, and we'll discuss this in a few slides as well, they are an educational value, but it's only being implemented at 6 of the universities that we surveyed. But that leads us into our 4th and final section of my seminar today, and that is reinforcing interdisciplinary education, or the 3rd chapter of my doctoral document. And so today we'll discuss mitigation strategies that are currently being implemented at the university level to some degree, and some degree of success, I would argue, as well as recommendations and conclusions I have for reinforcing this interdisciplinary knowledge that is important for agronomic management. And so I just wanted to just address the elephant in the room that none of us can see, but it is here, I promise. Can't we just add more courses? You know, if I've identified these weaknesses or these opportunities for growth, why don't we just add more classes to the curriculum? We can solve all the problems. We can add classes, but actually we can't. There are some significant and considerable time constraints that our educators have to operate within in each degree program. Specifically, think about that 120 credit experience. Once we remove general education prerequisite classes, that's 39% of the time the student has at the university. So we've already cut this down by 40%. Take also into consideration for their free elective classes, I can sit here and I can say, yes, every undergraduate student is going to put all 11 credits into agronomic classes, and they're going to really promote their career. But in actuality, there are other interests that students have besides agronomy. It's a concept that I'm still getting used to, but yes. Expected program duration. Students expect their programs to take 4 years. They don't want to stick around for a super senior year unless they absolutely have to. As well as when we think about 80% of students change their majors at least once, some students are switching to agronomy after their freshman year or sophomore year. I myself am a transfer. I switched majors my junior year. And so getting that all done in time was a little bit time consuming. But the main component I'd like to discuss is the competing courses and course options. And these are 3 snippets from some programs of studies. The first is from Kansas State University. And I do want to give Kansas State some props in that they do have pretty robust requirements for entomology, plant pathology, and weed science. About a 5 credit experience, 6 credit experience, typically 2 classes. But in this instance here, students have to choose between economic entomology and general entomology. Now, we can debate back and forth about what they're getting versus not getting in one class or the other, but the fact of the matter is students have to choose. And that's not just K-State. This is also at SDSU, and that students have to choose between entomology and lab and insect pest management and lab. So a 3 credit experience versus a 2 + 1 credit lab. So again, what are students getting versus not getting? We could debate that, but students, again, at the end of the day, have to choose. This is probably illustrated best, I would argue, by the University of Illinois at Urbana-Champaign's degree program, specifically for their crop major. In here, students are to select 12 credits from the following list of courses. And it's a little grainy, and for those of you that are in person, it's probably pretty small, but there's a substantial list. And if we assume each class is a 3 credit experience, that means we get 4. So choosing 4 classes, which ones do I want to take? Do I want to take principles of crop production? That sounds good. Let's do that. What about crop growth and management? Probably something we should discuss and learn about. But do I want to learn about agroecology? What about plant physiology? What about plant pathology? What about entomology? Students have to make choices in their degree programs. And at the end of the day, they are having to leave courses on the table because there's just simply not enough time. So the structure here makes students have to choose. But that leads me into my current mitigation strategies, specifically for reinforcing interdisciplinary knowledge that we know is required for agronomic management. There are 4 that I will present. I'll briefly discuss the first 3, which are capstones, internship experiences, and postgraduate education and certification programs. But the main meat and potatoes that I'm really excited to talk to you guys about is co-curricular contests and classes, and we'll discuss that last. So first and foremost, is our capstone courses. And so for those of you that aren't familiar with education terminology, a capstone course is essentially a senior level course that's designed to implement and integrate knowledge that's learned from other courses that students have previously taken in some type of comprehensive and meaningful way. Typically with capstones, you're looking at multiple different types of learning and reporting. So there's typically a written component and an oral presentation. So this is supposed to be a real culmination event and pretty synonymous with senior thesis and, again, culmination project. I gave that away a little bit there. The way we look at this within agronomy specifically, there was a publication that was agronomy specific. We're pulling all the pieces together. So you're learning all these disciplinary sciences, your capstones where you kind of implement it all together. And there are a lot of benefits with capstone courses. Specifically, their educational value is actually well supported by academic research. They are proven to be a good educational experience. And what's even better is that when we get student feedback from capstone courses, generally, and I'm going to say generally with italics around it, positive feedback. They also view these capstone courses as beneficial educational experiences. The cons with capstones, and this is a little bit nuanced here, time intensive on faculty to develop. So our faculty are disciplinary scientists, so developing an interdisciplinary class that helps pull together these other components is time consuming. The main issue I have with capstones, there's a lot of inconsistency from program to program. So what's done at K-State might be different from Iowa State, might be different from SDSU, and it's definitely different when we do at University of Nebraska-Lincoln. So it's hard to provide an end-all, be-all value of educational value as it relates to capstones. And so the next component I have for mitigation strategies is internships. And so I'm sure many of you are familiar, but just a quick review here. Internships are external experiential learning and work opportunities that students have to complete both in undergraduate and graduate degree programs. Specifically, a lot of times they focus on this experiential learning theory, which is really exciting. What we're looking at is it's more than just this work experience. We're applying these classroom concepts and constructs that we learn about in undergrad and graduate school and applying them to real world scenarios for the first time for a lot of times. This is directly what I did with Lee in North Dakota, applying field concepts, or excuse me, classroom concepts into the field. And what we do see with internships is that reflection on their experiences is key, and that's part of the experiential learning theory, which essentially has led to the development of pre and post internship courses at universities. That's that 2.8 credit requirement at 8 universities. The pros with internships is that they are present across many different companies within agronomy, and this provides diverse opportunities across the agronomic disciplines. So there's a lot of variety in what students can choose to pursue for an internship. And also, they're present across many different growing environments and cropping systems, because here's a fun fact: we grow crops nationwide. It's exciting, yes. But the cons with internships, and if we talk to some of the companies that host internships, they would probably disagree with this component, but internships are externally controlled by the companies or the governmental institutions that offer them. Essentially, our academic faculty and staff have no say. And this can lead to inconsistencies in the work experiences as well as the educational value that students can obtain from these experiences. Essentially what I'm saying, not all internships are created equal. And then even if they were created equal, the internship classes that we offer from university to university are not equal either. So for programs of studies within those 8 universities that have the 2.8 credit requirement, we're talking about pre and post experiences. For some programs, there might be an internship requirement, but no course. It's just a box to check by your academic advisor that you completed an internship. And that's leaving some of the value on the table. But that leads me to my third strategy, and that is postgraduate strategies. And that the first would be pursuit of postgraduate degree programs. So for everyone in the room here, pretty familiar with this concept. For a disciplinary focus, you're looking at traditional master's or PhD programs, and those are pretty ubiquitous across the United States. From an interdisciplinary perspective, we have a lot more limited locations. And so from a master's perspective, Washington State, Ohio State, University of Georgia offer master's degree programs that are interdisciplinary focused. From a doctorate level, we have the University of Nebraska-Lincoln, or the Doctor of Plant Health program, Woot, and the University of Florida, which is the Doctor of Plant Medicine program, which I would consider a sister program to the DPH program. And so that's exciting, that's cool, but the reality is that not all undergraduate students want to go on to graduate school. So this is not a strategy that is going to be something we can rely on for each and every student. So we have to have flexibility. Another option for reinforcing interdisciplinary knowledge would be professional certification programs. Specifically through ASA, there's a Certified Crop Advisor program, CCA, or the Certified Professional Agronomist, CP-AG certification program. These are really beneficial in that they establish professional benchmarks for interdisciplinary knowledge, specifically for nutrient management, soil and water management, pest management, and crop management. And another great value is that, and I think probably every academic advisor would agree, your education does not end when you get your degree. You have to continue it on into the workplace. And so CCA programs have continued education credits and training across these diverse groups that continuously require students to train and learn new things. But the main con with the postgraduate approach from a certification standpoint is that it's after graduation. And so maybe it's just me being optimistic here. I would like to think that there's something we can do at the undergraduate level while the student is at the university for 4 years to integrate and reinforce interdisciplinary knowledge rather than put it on the expectation of a work certification program essentially after the fact. And so that leads me to my last and very sexy concept, which is co-curriculars. And so for those that aren't familiar with what co-curriculars are, which I wasn't a few years ago, so don't feel bad, these are educational activities which complement curricular studies. Specifically, these are different from extracurriculars in that there is an implicit connection to the academic programs and student learning. Now, there is some level of separation from a curricular class from a co-curricular class, and that can be done in a variety of ways. One can be through ungraded activities or courses. Another, and this is the case for the crops team, this is offered through outside of regular class hours, excuse me. And then lastly, organized externally or separated from standard curriculum. And what's really nice about co-curriculars is that, again, there is academic research to promote their placement in our programs. One survey or one report showed that the educational value of co-curriculars include increasing self-efficiency, improving critical thinking and problem-solving skills, as well as developing marketable skills. And so this is a broad statement because it wasn't discipline specific, but that kind of helps culminate why co-curriculars are important. And what we've seen is that co-curriculars are being promoted at all different levels of education. And again, these are separate from extracurriculars, which gets a little bit nuanced at the high school level, but we're also seeing this at the junior and community college level, as well as undergraduate degree programs and graduate degree programs. One study I referenced specifically was that medical doctors were taking a co-curricular to improve their bedside manner. So that was really exciting, not agronomy focused, but just another instance of their value. And so the one I've chosen to select because of time today in my seminar is the NACTA, North American Colleges and Teachers of Agriculture Crops Judging Contest. And so this entity has both regional and national contests that are hosted with divisions for 2-year institutions as well as 4-year institutions. So junior and community college students as well as university, 4-year university students. And the one thing I really liked about the NACTA Crops Contest is that it focuses on all the agronomic disciplines. And here are some photographs of some of my beautiful students over the years. It's always weird taking photos while they're competing. But I wanted to break down the NACTA Crops Judging Contest into the components so you can see what this co-curricular contest basically is made of. And so the first will be a plant identification quiz, and that's a 75-question test. And they have to identify 54 different species or market classes of cultivated crops, about 30 forage and grass and legume species, or 60 to 70 different species of grass and broadleaf weeds, so plant identification. The next component is a math practical, and this is focused directly on agronomic-related math, calibrations, calculations, things that they need to understand how to do for their future careers. The next component is the agronomic exam. And the one thing that's really unique about the agronomic exam is that it is basically covering content that's covered on the ASA International CCA exam. It was made directly, specifically to help prepare students for the CCA program. So that's really unique. But then the last component, and the one that I'm really excited to talk about, the interdisciplinary focus, that is the lab practical. And so from the lab practical component, this is just me breaking down a few of the components, specifically mostly crop protection divisions, but then I do have a little bit at the end. From a plant pathology standpoint, identification of 30 to 45 different diseases and 9 different crop species based off of the symptomology that's being shown. And in some instances, students are required to provide optimal management strategies for these given diseases, and then provide basic biology on what these pathogens are, or basic biology information on the pathogens. From an entomology standpoint, again, 40 to 45 insect species at either the larvae or adult stage, again, in 9 crop species, and they chose 9 crop species to try to make it a national contest. So this includes peanut, this includes sunflower, not just corn and soybeans. And again, they're supposed to recognize management strategies, provide basic biology, identification of insect damage, as well as selecting pesticides to protect beneficial insects. So now we're starting into not herbicide, but insect selectivity. From a weed science perspective, identification of herbicide site of action, mode of action based off active ingredient, as well as pesticide formulations, mix orders, label reading, standard weed science information. But then there's also this other category, and this is just in interest of time, because there's a lot to unpack here. And so for those of you that might be viewing this, I don't know if I'll be making these slides available. This is a hyperlink. Otherwise, type into the Google machine, NACTA crops judging rules, and this will pop up. You can see how comprehensive this is. But this includes nutrient deficiencies, physiological disorders, common field machinery, precision ag platforms and concepts, basic plant breeding, integrated management programs, and again, much, much more. Not enough time today. These are the other co-curriculars that I evaluated in my doctoral document. Just in interest of time, I do have some slides at the very, very end if you guys get really curious. But the point is, I covered NACTA crops judging, the Soil Science Society of America Collegiate Soil Judging Contest, the North Central Weed Science Society, or WSSA Weed Science Contest, and then the American Society of Agronomy Collegiate Crops Judging Contest, which is just ever so slightly different from NACTA crops judging. And so with that, I do want to note that all of these co-curricular experiences are great learning opportunities for our students. And these are co-curriculars that these programs of study can leverage as they move into integrating interdisciplinary knowledge. But that leads me to my final recommendations and conclusions. How do we enhance interdisciplinary knowledge? So my first component is promoting and emphasizing undergraduate internships paired with reflection-based coursework. So this was pretty solid across most universities, 8 of the 11. I would like to see internship classes developed at the other universities and promotion of internship experiences. The next is incorporating integrated management into capstone experiences. So for those of you from UNL that have taken that class, this is in our capstone, but it's not in all capstones. If a capstone is supposed to be a cumulative, bringing all the pieces together experience, integrated management, I think, fits perfectly with that type of description. The next would be promoting the use of elective credits for appropriate aligned coursework. We're not going to get all 11 credits. It's just not going to happen. But if we can promote use of those credits to further broaden students' agronomic training, this will be very beneficial. The next would be promoting postgraduate certification programs after graduation. And I would say that we do that to a pretty well degree. There's over 13,000 CCAs in North America. And then last, but definitely not least, support undergraduate co-curricular programs, specifically through the development of accredited elective contest preparation courses. And so accredited, these are my personal beliefs and recommendations. Courses for co-curriculars need to be an accredited experience, mainly to have access to department resources. If the crops team was not an accredited course, I question if I would have had the resources that the department provided to me or space in the greenhouse. It starts to limit the educational value of these experiences. And then second, students need to be recognized for their time commitments and the educational value that these co-curriculars offer. While it is separate from their curriculum program, it is a valuable experience. The next would be elective. And this is my personal belief in that co-curricular experiences should not replace other agronomy courses. This is not direct competition for any other course. The way I view this is that this is essentially a reinforcement of concepts being taught in other classes. And then lastly, contest preparation course. And this is my personal belief, and I think the belief of many of my students, if you were to ask them, and that active and purposeful preparation for these co-curricular experiences are essential in order to get the full educational value that they provide. If you just simply show up to the contest, I'm sure you'll learn a thing or two, but you will not truly master the content until you actively prepare for that experience. And so with that, I did want to run through my graduate experience at UNL just real quickly. This is just for fun. So since August 22nd, 2016, 1,849 days have passed, which on my tracking app on my phone, I've logged 12,747 work hours. During that time period, I completed 114 credit hours across 45 different courses. I had the opportunity and utmost pleasure of teaching a total of 54 undergraduate students over 8 semesters, but it is important to note that there are many repeats. Jared, for example, I believe I had you all 4 years. Is that true? Yeah. So there were a lot of repeats. But being part of the crops team, I had the opportunity to travel 7,218 miles with the crops team to various contests. And then during this time, I had 5 crops contests hosted either through FFA or SACES for a total of 1,195 students. And it is important to note, I did that with a lot of help. It wasn't just a one-man army. With my experiences with the JAWA Lab, I had the opportunity to publish 2 going on 3 first author papers and 2 second author papers, which equates to 10,886 lines of R code. I also have the displeasure of discussing the one broken topper window in truck 339A that I started off my experience with the JAWA Lab in. And then lastly, with the JAWA Lab, I had the opportunity to compete in 2 weeds contests with a perfect team calibration score, guys. So that is what perfection looks right here. That's Parminder, Andre, myself, and Ethan, 100%. Yes. But then the utmost pleasure of being outscored by at least one of my previous students. And I believe that was Roger Farr. Specifically, the student did become the master in that point. But the main point, lifelong friends, professional acquaintances that I can count on for the rest of my, not my academic career, but my career. We're moving on. But at this point, I'd like to touch on my acknowledgments, and I'm running over time, so we'll get to the questions. I do want to just briefly acknowledge Dr. Gary Hine for serving as my advisor and mentor as I went through the last 5 years at the university. Your edits to my document and the value that you've provided my career is remarkable. I'd also like to briefly recognize my DPH committee, which is listed here, as well as our support staff, Kelly White, and then the department heads that I've had the opportunity to work with, most recently, Dr. Martha Memo. Her support of our crops team and myself as a student is absolutely 100%. I don't have the words to describe how grateful I am. Thank you. The DPH program, all present and past students, for those of you that are in the audience and joining us online, thank you for your kinship. The discussions we have in that office are unique, and I miss it. More specifically, Dr. Lee Breeze for serving as a mentor and friend for me. The JAWA Lab, all present and past members, Dr. Ethan Barnes for teaching me how to code and really helping me along the way, and Dr. Amit Jala for allowing me the flexibility to do all of these things at the same time. It's also important to recognize the crops team, all present and past members, for joining me each and every week and sharing our passions for agronomy together. My TAs that help make things flow smoothly, a co-coach, Lizzie, right here, and our new coach, Jared Stander, who is going to be taking over for me after I've left. Then it's also important, I want to thank Casey, which is our department support staff, as well as some of my fellow graduate students, Milos and Samantha, that I had the chance to work with, as well as my friends and family specifically, and this is a little preemptive, Dr. Mary Happ for her friendship, as well as the support from my sisters, Sarah and Megan, and my parents, Mike and Suzette Striegel. And then lastly, as we wrap up this whole conversation from a Bear perspective, Craig Lamoury and Dr. Katie Price have really pushed me to continue to work on this document and on these slides. And all of this wouldn't be possible without the flexibility of my supervisor, Al Strachey. So thank you for allowing me to start my career with Bear while also finishing this up. with that, I would love to take any questions anyone may have. Thank you. Just a little over an hour. 10 minutes over what we planned. Yeah, I talk. Yes.
So, do you think by incorporating a full experience learning model into a capstone or internship course, reflection in that overall takeaway from that?
Okay, I'm going to summarize what you said because I don't know if the people online can hear. Lindsay asked a question specific about the experiential learning theory and the Kolb model about whether it is beneficial to incorporate it into an internship class. And the answer is yes. So you can view an internship as just work experience, or you can view it as what it actually is, and it is a experiential learning opportunity. And so incorporating the Kolb's model, where the main component is reflection after the fact, that is required from transitioning these abstract thoughts and theories, implementing them into real life and work experiences, and with that reflection, you're able to make that into a concrete experience that you have a good understanding of. So the answer is yes. I would say from an internship perspective, a pre-internship seminar class of maybe like 0.25 credits to prepare students for that internship. And then the main focus being on a post-internship reflection would be key. Thank you.
Hey, Adam, can you hear me okay?
Yes, I can, Amit. Thank you for joining us.
Yeah, thanks for your presentation. I really enjoyed watching at least half of your presentation. And my question is, so now, Adam, you have DPH degree, you have master's degree in wheat science, and now you have a job. So when it comes to the real world situation, what is your take on whether master's degree was complementary with your DPH degree, or either of them is not needed, or what is your take on for current DPH students or some other students?
That's a little bit of a loaded question, Amit, but thank you for it. So I will be completely candid. I have a very hard time separating what I learned in my master's from what I learned in my DPH degree from what I learned as a teacher of the crops team. So they all kind of blend together. From a master's perspective and my current role with Bayer, without a master's with you, Amit, I would be lost in terms of how to conduct a weed science research and how to report data back. So I would say if you're working in a research-focused field, a master's degree is absolutely essential in order to understand that concept and those theories. And you can further that into a PhD if you're planning on staying into a disciplinary science. The one really exciting thing about my position with Bayer is that, so I'm a crop protection technology development representative, and so I cover mostly herbicides, but also fungicides and insecticides. And so that is where the DPH program has really helped me with that background knowledge and comprehensive training in entomology and plant pathology that I feel very blessed to have. And so from my personal experiences, it's hard to say if I could do the job with just the master's or if I need just the DPH, but I would say the whole package that I put together with you, Amit, and Dr. Hine has definitely been very beneficial for my experiences with Bayer. Does that answer your question?
Yes, yeah, no, glad to see that both the degrees were like complementary each other.
Yeah.
Thank you.
Adam, this is Chuck Francis. I have a general question and then one rather specific philosophical question.
Okay.
Yeah, first, you defined agronomy very nicely, and also all the information you gather is going to be really helpful to us as we continue to struggle with our undergrad curriculum and figure out what to include and what not to. But you mentioned the definition of agronomy as including integrative stuff, and I fully agree with you that we're maybe the premier integrators on the campus. But you also mentioned holism and systems approaches. Mm-hmm. And in your evaluation of these various programs, which is kind of a bean counting of what people are doing, to what extent were you able to dig a little deeper and find out how much was really included in these courses in holistic approaches and whole systems analysis?
So I guess I'll answer that before we go on to the next question. Dr. Francis, that is a great comment and I think notice in that. So with this program of study, with the survey that I did not go in depth because what I would have really preferred to have done would have been to obtain a syllabus for each and every course that's listed on these programs of studies in order to decide, does this cover agroecology? Does this cover entomology? Is this do I want to place these credits in this category? Do I separate them out? With this current survey, we did not go to that level of in-depth. What I chose to do was I went based off of the title of the course. And then if it was a little bit blurry, a lot of these programs of studies would provide like a short paragraph summary of what these courses were. And I would read those if I wasn't sure about where to place a course. But for the most part, we did not go to the in-depth level, I would argue, that is needed for a comprehensive survey of what is and is not being taught within each course. So unfortunately, I am going to have to let you down there.
Well, that would take another 5 years probably.
If I would have started when I first began this, we would have got.
There is a question on chat.
I have a philosophical question then, Adam. How would you distinguish between training and education and also between teaching and learning?
Oh. So I would say, and this is just philosophical, my thoughts here, immediate responses about the difference between training and education. So I think training is much more purposeful and pragmatic. So we are directly focusing on things that are realistic to field scenarios and things that the students will absolutely be exposed to in their careers. From an education standpoint, that's where we start to implement some of these philosophical thoughts and questions, theoretical concepts, not necessarily unimportant, but maybe not as directly not necessarily integrated, but I'm using that word too many times today. Maybe not as directly implementable in the field, but definitely important discussions to still have. So that's the way I would separate training and education. Now, as for, what was the other one? Learning, and what was the other one?
Teaching versus learning.
So teaching versus learning. So I think, and Jared, you'll have to back me up here. If I'm at the front of a classroom and I'm lecturing, or if I'm presenting a PowerPoint, or if we're going through a plant ID quiz, the entire time I'm teaching, the entire component and all the material that I'm providing, I would say culminates into teaching. But what the students garner from what I'm teaching is learning. And that's not always as comprehensive as we'd like. There is some knowledge transfer loss. So even if you teach, let's say, integrated pest management, if the students don't learn all the concepts that they need, then they didn't truly get the full training or education that they need within that different component. That's my philosophical take, and I hope that works for you.
Well, I guess I would ask then a follow through, if they don't learn, have you really been teaching?
Not effective.
I ask myself.
And I think that all of our educators that might be joining us would agree that not 100% of our faculty and staff are effective teachers every day.
There is a question on chat. You want to read it?
Yes.
That way.
So this is from Kevin Donnelly at K-State. The capstone here. Our capstone is, what was the question? Okay, our capstone is more current issue based, not really a summary of agronomic content. How do we ensure capstones based off of agronomic content is truly an integration or just a review of other courses that they already paid for? Dr. Donnelly, great question. I would say, and this is again me just being philosophical and theoretical here, you have to add value. And the way I view this is just like we feed grain to livestock to add value to the grain that they're consuming, we have to add educational value. And this is, Dr. Donnelly, I would agree, if this is simply a review of other coursework that students have completed successfully already, it will not be an educational value that's worth pursuing. If it transcends what they've been taught and adds value in either going into a deeper depth or breadth to specific concept areas, and that it no longer is a review and is now a new experience to like the, increasing essentially their content knowledge from what they learned about as a sophomore to what they're now capable of understanding as a senior with more agronomic experience, I think that that's the difference. But I would also argue, and this is a good point, understanding the current issues within agronomy is, I think, paramount as well. If you're only reviewing integrated management, that's all good and fine. You have to know what's actually happening out in the field. Does that answer your question, Dr. Donnelly? You can just chat back if you like that.
Yeah, thanks. Maybe I didn't know if you could hear me. So,
Yep.
Yeah, and I think the follow up on that was, I think that's where I feel like the competition activity offers a better opportunity to do that. Unfortunately, the students that really need that probably aren't stepping up and doing the competition. So it's kind of like everything.
I would agree. We get from some of these co-curricular contests, you get the premier students, the best of the best, students that want to go above and beyond the expectations. And so there is a significant portion of students, I think, that could benefit from NACTA Crops judging contests or any of the other co-curriculars that I reviewed that won't make that choice. And so implementing that and promoting that, I think, is important.
I think with that, we'll call it quits, and let's give Adam another round of applause.
Thank you for joining us today, guys.
Thank you, Adam.